Okay, now in this video, we're going to look at what we could call cliff problems. And we're going to talk a little bit about the intro part too, but we're going to focus down here on these cliff problems to include an example problem. All right, so combining the constant velocity, right? So the constant velocity horizontal, I forgot the word motion here. So constant velocity horizontal motion and the free fall vertical motion of a projectile, a parabolic path is traced down. Okay, so regardless of what the question is, you're always going to get a parabola. Now, based on what is happening, is it going to be half a parabola or is it going to be a full parabola? So there are two types of problems that we're going to encounter. The first one that we're going to call a cliff problem. Okay, now I'm putting the word cliff in quotation marks for a reason. Okay. So what happens is the initial vertical velocity in these problems is 0 or 0 meters per second. So sometimes these will be referred to as launched horizontally. Okay, and so what does that mean in terms of a picture? So the reason why we call it cliff problems is a lot of these questions are simulated to be like off a cliff or off of a table. And so what happens is you start out with only an initial x, right? And then you're going to end up traveling down to a certain range, right? Now, the thing that matters here, and regardless, this also goes way back to free fall, something that we did mention, but the only factor for the time is the height of the cliff. Okay, or the height from which the object is being dropped. So the only factor for time, okay, so if I drop the object and release it out horizontally, as long as this is the same height, then the time will be equal. Right? You're going to find that on multiple choice questions saying that you drop one and one is fired out, but they're from the same height. Which one lands first or second? Well, it's a trick question. They're going to land at the same time. Okay. Now, the second one is when we launch okay, so the second type of question is when we launch it at an angle. Okay, where the projectile has both an initial horizontal and vertical velocities. Okay, and we'll get into solving these in the next video, but we're going to mention it here. So if I think about you're kicking a football or kicking a soccer ball, right, cannon being fired, so we're going to launch it at an angle, and it's going to trace out this full path, right? It's going to have this full parabolic path, right? And just like it, so it'd be equal to in free fall if we were throwing the object upwards. And the only thing we're doing is now introducing in that horizontal motion, right? So that just creates this path of a parabolic shape. Okay, and again, the connecting piece between the two types of motion is time. And we say that the motions are synchronized. So the vertical and horizontal motions move off together at the same time, and so they're synchronized. They're not, one's not going to be any faster than the other. They're going to be done at the same time. Okay, so now what this video is specifically about is that these cliff problems. Okay. When I mention cliff, it's launched horizontally, okay, where the initial vertical velocity is 0, right? And an easy way to look at it is like, how did the formulas break down, and what are the key parts in the horizontal and vertical motions, okay? So if we look on the horizontal side, right, so our VOX, our initial velocity, will be our final velocity at the end, okay? And it's going to be our only velocity given. Okay, and so we know the acceleration, the x direction is going to be 0 because it's a constant velocity. Remember, the horizontal is our constant velocity motion. Okay? And so that's why this is also true, because our initial and our final velocity would be the same in the x direction. And so again, really there's only one formula here, and it's going to be VOXT, right? Or displacement, or delta x, right, is equal to VOXT. The other formulas just break down to be this or this, okay? Now, on the vertical side, we're going to say our VOY is equal to 0. We know that our acceleration is going to be g, which is going to be either negative 9.8 or negative 10, however you want to call it, right? Again, it's all dependent on if you want to use, if it's a multiple choice question, you're probably going to use 10. If it's a free response question, you're probably going to use negative 9.8. And so the rest of the formulas just break down as such. So if I take the final velocity in the x or in the y direction, okay, well, the initial velocity piece just goes away, which just makes this negative 9.8 t, okay? Or, again, if you're using 10, it's going to be negative 10 t, okay? So what it's doing is gaining vertical velocity, right? Where the initial velocity, the horizontal velocity is not changing, okay? And then our y, our delta y, or a change in y, it's just simply going to be negative 4.9 t squared, or again, if you're using 10, it's going to be negative 5t squared. Okay, this is important because oftentimes this is how you're going to find the time. Okay, and then you have that other formula to find the final velocity in the y direction, or in the x direction, or excuse me, in the y direction. It's going to be negative 19.6 delta y. Okay, or again, if you're using 10, it's going to be negative 20 delta y. Okay, and notice that's going to be VF squared. So if you want to find VFY, right, you have to take the square root of that. Okay, but again, no, so you do need to be careful. Again, if you're going to use 10, it's going to be negative, the square root of negative 20 delta y. You do have to be careful in this question here, or if you use this equation, delta y has to be less than 0. So you have to make this negative. Okay, that's assuming that your initial position is at the your 0 point is the initial position, and then it falls down. Okay, so let's look at an example, right? So here's something. So after failing physics, Rob's mom throws his phone off a cliff horizontally with an initial velocity of 12 meters per second. And if the cliff is 27 meters tall, typo there, sorry, how far from the cliff will Rob's phone land, and or where it will shatter into a million pieces? Okay. So here's our situation. So Rob's mom is throwing his phone off at 12 meters per second. And we're asked to find where does it land. So what is its range? It's delta x, where they give us a delta y, or a height of 27 meters. Okay. So what we're going to do is I'm going to split my paper, if you want to say, into two columns, vertical and horizontal. And my goal is to get time on the vertical side, because then that answer becomes time on my horizontal side. Okay. So as I mentioned, you're going to use this equation, this delta y equals negative 4.9 t squared, right, to solve for time. And so you can't memorize, this formula is not given to you, but I would memorize how these formulas break down as you go through projectile motion, just because the solving is going to be the same, right, regardless of what it's going to, if you're looking for initial velocity or time, something. Okay. So what we're going to do is we're going to divide by negative 4.9. Okay. And then ultimately we're going to take the square root, because this is t squared. So I'm going to take the square root of all this. Okay. So it's going to be the square root of delta y over negative 4.9. Okay. Now, you do have another thing you have to be careful. This is negative. Again, you have to make sure that delta y is negative, because the object is falling down. Okay, so just remember that delta y has to be negative, because the object is falling down. So now I can just plug in my numbers. So we have a height of 27 meters, or a delta y of 27 meters. And so we're going to do the square root of negative 27. Again, we're falling down. Okay, and then we're going to divide that by negative 4.9. So negative 27 divided by negative 4.9. And we're going to get an answer of 2.35 seconds. Okay, so that time, right, remember, this is the connecting piece between vertical and horizontal motion. So it's going to fall 2.35 seconds, but while it's falling 2.53 seconds, it's also going to move horizontally 2.53 seconds. So now we can find where is it going to land. Okay, so we're going to use our delta x equals VOXT, and we're going to just simply solve this for delta x. So it's going to be 12 times 2.35. Okay, so where is Rob's phone going to land? Let's do it in the calculator real quick. It's going to land out at 28.2 meters. Okay, so this distance over here would be 28.2 meters. Okay. All right, so in the next one, we're going to look at specifically when we launch him up at an angle, and then we'll look at another example problem or an example problem for that.